Hi there, I'm Ben Abel. I'm Technical Director and also in charge of Research and Development here at Hilson Moran. Hilson Moran has been using simulation for over 20 years. We use a range of simulation processes going from sort of daylight processing, daylight assessments, through to acoustic assessments right across the board, and obviously using products such as Ansys Fluent as in our fluid flow and our assessments for a range of both internal environments and external environments. Each building is unique, so unlike a car or a plane, every building is in a unique design and in a unique position. So everyone is a prototype. Also the timescales are getting shorter, so the turnaround needs to be quicker. So the pressures are, we need to do everything almost from scratch every time.
I'm Julia Mackey. I'm a technical consultant at Hilson Moran, and my main responsibility is performing CFD simulations for both the internal and external built environment. I've worked on the Ropemaker building in London, and I've used CFD simulation to assess the interface between the external and internal environments. In particular, this was relating to revolving doors, and the client was concerned that in the winter, particularly where there's heavy footfall, how are we going to predict the amount of cold air that could be coming in and potentially interfering with the heating design. And so for this we used a transient simulation which was very insightful. This has allowed us to show the dynamics of how cold air would be introduced in a worst case scenario, and how this was really travelling a surprisingly far distance to the back of the foyer, and this really did highlight the need for mitigation in terms of more furniture, particularly where the seating area had been chosen.
One of the key areas we've used simulation for has been the entrance lobby. So one of the requirements in London is that entrances need to be inclusive. Previously you might have had a revolving door and a separate pass door for people who have additional needs. Now is a requirement that the entrance must be inclusive. So we have an opening door, so it slides open, but that has the implication that it can let a lot of either hot or cold air into it. So we used Ansys to produce a simulation to say, if you open the door for a short amount of time, what are the effects? So 5 seconds opening door time. And we also did longer door opening, so 20 seconds, open the door for 20 seconds, close the door, and then see how quickly the space recovers. So that was really key to demonstrate to the client how quickly that space could recover on a cold day.
I'm Joseph Beartu. I'm the CFD and wind consultant here at Hilson Moran. In my day-to-day work here at Hilson Moran, I do a lot of wind assessments for working with architects and planners to make sure that the wind conditions around the building that the architects are designing is acceptable for pedestrians who might be walking around nearby. So a lot of the work that we do is to prove that the design is acceptable, but sometimes when we do the assessment the design is insufficient, and so we have to work with the architects to improve the design and work with the planning officers to improve the conditions around the building.
On a day-to-day basis, I perform simulations for air movement inside buildings and as well as externally. So this is to make assessments of ventilation systems, the dynamics within the room, and achieving temperatures in line with the mechanical design. And this can also involve the external built environment, so wind dynamics around master plans, or even on a smaller scale looking more locally at natural ventilation design, so the real dynamics of how it's interfacing with grills, that sort of thing.
We were involved with 3 of the Qatar 2022 World Cup Stadium, most notably the World Cup final stadium, Lusail, which obviously we all saw on the telly. Really key as it had internal both ventilation and air conditioning, so that was very difficult because we were ventilating all the occupants in the stadium, but in a novel way. So we weren't ventilating the whole space, conditioning the whole space. We were just conditioning the space around the people, so it's more energy efficient. And we also had to make sure that we were hitting all the thermal comfort metrics set by the World Cup Delivery Group, the Supreme Committee, to make sure that everybody was going to be comfortable.
What would happen if we didn't have simulation available to us is we would have to retreat back to very simple designs that have already been done before or have been tested in the real world. What simulation allows us to do is to explore designs that are innovative, new, different. And that's the best thing I think about working in this career, is I'm only ever brought into a project when they're trying to do something different, when there's a problem that no one solved before.
The overall industry challenges are that each building is unique, so we have to take a fresh approach each time we look at a building. We also have obviously more time pressure on each design, so the pressures are both that each design is new, but also the turnaround time is getting shorter and shorter, and people are expecting more. So previously we used to do steady state type simulations. Now we're doing more and more transient simulations, looking at how the airflow around the building moves minute to minute as opposed to an average. The future simulation is going to continue to grow. We're going to use more and more simulation across a wider range of applications. CFD, I see the use of AI really improving the speed and delivery of CFD. That's always where we've struggled, is to turn things around quickly. AI can obviously enhance that, give us speed ups that we could only dream of today. So, and CFDs and other simulations can be used in more and more applications, more and more parts of the built environment. It really helps us to show our clients all these interesting pieces that they're interested in to help produce a better building.
It's difficult to quantify the amount of time or money that we save with simulation, because in our work we tend to use simulation on a project or not. It's not easy to compare one project with another. But certainly we do use the simulation. When we do use simulation, it saves us an awful lot of time in terms of delivering an efficient solution quickly and communicating that to the client.
Without simulation, we would not be able to demonstrate the effectiveness of our designs. By using simulations such as Ansys Fluent, we can show our clients that our design would deliver what we said it would.
What I really love about CFD simulation is that every day is different, really. There's never been a project where I could have said, that's absolutely the results I was expecting to see. You'll always learn something, if it's about the physics or what design combinations work.
The impact of sustainability and simulation has been considerable over the last few years. So we have both regulatory requirements, so minimum standards for energy and carbon, but then we also have systems such as BREEAM, LEED, and wellness that we use to drive our simulations to make sure that the offices or whatever space we're designing, meet those requirements.
One thing I find particularly easy through working with Ansys simulation tools is the support they provide. So there's a wealth of material online, so user guides which really guide you through each process in the workflow, and there is direct support available, which is invaluable when you can actually talk to someone and they can understand your query down to the detail.
The thing I most enjoy about using simulation and working in this sector in particular is that I'm always working on something new, something interesting, something different. And also with working in this sector, in the building sector, you often can end up walking past the building that you helped to design, walking past, and you can say, well, that particular feature of the building is down to the work that I did. To be able to feel like you've had an influence on the world, to be able to say that you've made something a bit better.